So today what I want you to think about, when we use systems, linear systems, and graph them, when is the best time to do that? And then I'd like to know what you think some of the disadvantages to solving those systems are. Now, during our discussion, you'll find out that a lot of the times graphing is nice, but sometimes it's not accurate. Okay? And that's why we end up doing things like this. We go and spend our time learning about solving linear systems by substitution. Now, for today's lesson, we're going to understand what math symbols are used for systems, i.e. equations that have two or more equations that are going to be related to each other. Now, we're going to also show the progression of a system when we rearrange. Okay, so sometimes we go and take an equation, we change it, and we want to still refer to it as, say, equation number 1. I'll show you how all that works. And then we're also going to reinforce checking using the left side, right side concept we studied last day. Now, we'll know we understand what's going on when we realize that we, well, can use the math symbols and its systems, okay, and its manipulations. Now, we're going to understand that the solution of a system is always a point and can be stated as a solution to the system. Now, you're also going to be able to check or verify if, let's say I give you a solution, you should be able to check if that solution works for our system. So what I need you to remember is that every system that we have literally is just a point. Now when we solve a system, we need an x or a y. And all we're doing is we're just solving for our system. So before we would just solve for y to get an equation, this time we're going to take two equations with two unknowns, exactly two unknowns, like an x and a y, and we're going to solve it. So in this instance, we're going to label the first equation 1 and the second equation 2. Now, when we go and solve for one of our equations, we try to use the simplest solution. So we solve for y for the second one because y is already linear, so we're good to go. And now that squiggle sign that you see really means that it's a system. Now you'll notice as I go along, I always rewrite my system numbers. And then I sub my second equation into my first equation, And you'll notice that I now have 3x minus 2 bracket negative 4 x plus 7 equals 8. And you'll notice I'm highlighting the minus 2. You're going to take minus 2 and you're going to distribute into the bracket. And you're going to get the following result. 3x plus 8x minus 14 is equal to 8. So now we have to collect like terms on the left side. And we're going to get 11x minus 14. Now we just move the minus 14 to the other side, and we get 8 plus 14 is 11x. And then we add those two together to get 22, and we have 11x is 22, and we find x is 22 over 11, which means x is equal to the value 2. Now, we need to find the x value. So we're going to go back to our second set of equations, and then what we're going to do is we're going to let y equal the original equation, but we're going to sub x equals 2 into that equation that we rearranged. So I'll just punch it in. Negative 4 times 2 plus 7. We get our final answer of negative 8 plus 7, which gives us y equaling -1. Now, we're not done yet. Once we've done that, we have to state our final solution. Therefore, the solution is something. So, our solution is always stated in the form bracket x comma y to -1. Now you'll notice I'm always writing this as a point where we have 2 as our x and -1 as our y. Now what I'd like you to do is I'd like you to take a moment and do a quick check to see if this solution was correct. Now, normally if we were doing a math problem, I would tell you check before you state your final answer. So we practiced this yesterday, and what I'd like you to do is I'd like you to make sure that this system, 3x minus 2y equals 8, and 4x plus y equals 7, i.e. the original system actually works. Do your left side, right side checks, and I will show you the answer. So pause the video right here and we'll check. So now let's begin. So we want to check, we're going to check to see if, well, for our solution, xy is equal to 2, -1, to see if that works in our original equation here. 3x minus 2y equals 8. And what I want you to do is I want you to take the time to do the left side, right side check that we did yesterday. Just follow the pattern. So remember, we have our LS, which is equal to 3x minus 2y. I'll start with that, and you do the rest, and then I'll show you. Pause it here. You'll see that our left side, when we substitute, you'll notice we end up with 8. So now, let's do the same for our right side. And you notice RS equals. So now we say, since the left side is equal to the right side, therefore 2 -1 is a solution for equation number 1. And now do the same for equation number 2. Pause right here and I'll show you the solution. So we get something similar to this. So when the time comes, I'm going to ask you to check your solutions for certain equations. You're going to get one more problem that has that. For this equation, I'm going to let equation 1 be x plus 4y equals 17, and then I'm going to do the same. I'm going to let the second one be the same. Now, for the next problem, I'm going to solve for x because I like using x. So x is equal to -4y plus 17. So we're isolating the x on the first equation this time. So now let's sub equation 1 into 2, and we're going to get the following. 3 bracket -4y plus 17 is equal to 12. Oh, wait. Minus y equals 12. And now let's distribute normally. So you're going to get -12y and then plus 51 minus y equals 12. Collect all your like terms on the left side, and you're going to get -13y plus 51 is equal to 12. Now, move the 51 to the other side, and you're going to get negative 13y is equal to 12 minus 51. And negative 13y ends up being negative 39. Now divide both sides by negative 13, and you end up with y is equal to 3. Now make sure you highlight that with a box around your work. Then what I want you to do is you're going to go and substitute, back substitute we call it, into the original equation for 1. So we're going to substitute y is equal to 3 into equation 1. And we have x is equal to negative 4 bracket 3 plus 17, which ends up being negative 12 plus 17. So now x in the end is going to be just 5. I am not going to do the check, but what I want you to do is I want you to do the check for yourself, and then I also want you to finally state the final solution. So you're going to say, therefore the solution is blah. So now we'll begin our check, and you're going to get the first part right here. You set your left side and your right side, you do your substitution, and you're eventually going to get both sides equaling each other. Now that you've done that, you're going to say, since the left side is equal to the right side, therefore it works, or this point is a solution, something like that, okay? Take the time to make that happen. And now, what I want you to do the second check, and I'll show you what the answer is. And here it is. And we're almost done. And we end up with 12 as before. So since the left side is equal to the right side, therefore 5, 3 is a solution for equation number 2. And we're done. So just take a moment and look at that. So all we have to do now is we just have to state our final solution. Therefore 5, 3 is the solution. Now remember that sometimes your x values and y values represent different types. So what you might say the solution is 5 dogs and 6 cats. I don't care, but that's basically it. Thank you. Okay, so I'm going to label equation 1 as y equals 2x plus 1 and equation 2 as y is equal to 5 minus 4x. So now we're eventually just going to sub 1 into 2. So essentially you have y equals y, or basically 2x plus 1 is equal to 5 minus 4x. Now what we're going to do is we're just going to move all the x's to one side, and we're going to get 2x plus 4x is equal to 5 minus 1, which equals 4, and 2x minus 4x is negative 2. Divide both sides by negative 2, and you're going to get x is equal to negative 2. And now what we need to do is we just need to calculate the final substitution. So now we're going to sub x equal minus 2 into equation 1, which really means we have this. Y is equal to 2 times negative 2 plus 1, which means we have negative 4 plus 1, which means y is equal to negative 3. Now, you'll notice how there wasn't any there wasn't any specifics on saying check. If you're not sure, go and check. If you're pretty sure it works, just say therefore the solution is -2, -3. So this problem is going to be particularly difficult because of the fractions that we have here. There will be some use of the LCM later, but first, just solve the first equation in terms of x and restate your system to be what you see here. So you get x is equal to -y/3 minus 1 over x/4 plus y/2 equals 1. Now we're going to call that second one equation 2, and then what I need you to do is I need you to sub 1 into equation 2. And now this is where the long drawn out difficult problem is. We're just going to do our substitutions and then we'll do our LCM calculations. So you'll notice how I replaced x with -y/3 minus 1 equals 1. So this is the complex part. Now literally we're just going to multiply by 4 as our LCM. And when you multiply by 4, you're just multiplying the top of each bracket by the number 4, and then you're going to do a kind of cross cancellation with anything that's a fraction. If you have a whole number, all you're doing is just giving me the answer back. 4 divided by 4 gives a 1 and a 1, so that whole bracket that we have over top of our first fraction just comes out as -y/3 minus 1 plus 2y equals 4 times 1, which is 4. Now what I want you to do is I want you to drop the brackets. Now when we drop the brackets, we're going to get -y/3 minus 1 plus 2 equals 4. So now you're just going to collect all your whole numbers on the left side. So on the right side, you're going to get something equals 4. Nothing changes, but you're going to get -y/3 plus 1 equals 4. So, I could move the 1 over to the other side, or I just multiply everything by 3. I just like multiplying by 3. I love it. Multiply everything by 3, and what will happen is you're going to get all that over 3, 1 times 3, and 4 times 3. So now you're going to get -y, I believe, plus 3 is equal to 4. Now you could have simplified by moving the stuff all over to the one side. It's up to you. And we end up with 12 on the right side. So now we'll solve for y. Y ends up being, in the end, 3 minus 12, which means y is equal to -9. So now that I've got y is equal to -9, I have to back substitute. I have to take the y equals -9, and we're going to sub that into equation 1 since it's already solved for x. It's very important that anytime you solve for one variable, you always use that to help you back substitute into your equation. It's very, very important. Now, this next substitution is just going to be x is equal to -9 in brackets over 3. But there's another minus sign in front. Make sure you catch that, and then -1. So it ends up being 9 over 3 minus 1. So x ends up being 3 minus 1, which is our solution. So x is 2. So now all you have to state is, therefore, the solution is, well, xy equals bracket 2, -9. And we're done. Alright, so let's explore this problem again. So now we're going to do exactly what we did before, where we took a look at the first equation and solved for x. Now, sometimes you guys have some issues with these type of equations. So what I would tell you to do immediately is to multiply all of these numbers by the LCM, and you're going to get the following equation. We have x plus 2y equals 4. So if I took 4 times this part here, we're going to end up with just x, because 4 divided by 4 will give us 1, so now x is left alone. Now 4 divided by 2 will give us 2, and 4 times 1 will give us 4. So now let's do our full solution. So let's sub 1 into 2. But before we go on, let's make sure we understand how we went from here to here. Some of you guys have issues with that. So we start in this nice little bubble here with x over 4 plus y over 2 equals 1. So this is what I call my aside. So now we're going to multiply by the LCM of 4. So this times 4, and this times 4, and this part also times 4. So now we're getting our cancellations. 4 and 4 cancel out to be 1 and 1. And 4 from this part and this cancel out to be 1 and 2. And this last part here just comes together to be 4. So let's rewrite that. So we have x plus 2y equals 4 as our answer for our new equation. So don't be afraid. You can actually change both equations at any time. So if you're getting more sophisticated with it and you want to make your life easier, you can take 2 equations and go for it. Okay? Subbing 1 into 2, we get the following. And dropping the brackets, we get. And now, since I hate fractions, let's just multiply everything by 3. So in essence, we're doing this to each one of those numbers. Each whole number I look at as a fraction, as like -1 is really -1 over 1. 2y is just 2y over 1, and 4 is 4 over 1. So now when we multiply through, we get some cancellations. This disappears with this, and we're left with 1. And the rest, you just distribute normally. Now, here's our next line. And we get this. Collect your like terms. And now let's solve for 5. Y. And now we get this, which means 5y is 15. Y is 15 over 5, so that means y is equal to 3, which is what we expect. And now let's back substitute. There we go. You'll notice when I substituted my y into my equation, I left it in a bracket. So now we get x is equal to, well, simplifying all of that, we get -1 minus 1, which means x is equal to -2. So this was just an alternate way to make your life a lot easier. Okay? Alright guys, have a good weekend. And now we're about to work with this next problem. So we take this new system, we label our 2 equations, equations 1 and 2. Then what we're going to do is we're going to leave the first equation, and we're going to divide the second equation by 2. and rearrange for the lone y value that we have. And as usual, we're going to label each equation 1 and 2, and then restate our equations to be 2x plus 3y equals 3, and y is equal to negative 2x plus 5. And equation 1 and equation 2 are labeled again. And now let's begin our calculations. Let's sub equation 2 into 1. Now in doing so, you're going to get 2x plus 3 bracket negative 2x plus 5 equals 3. Now you'll notice that there is a plus 3 in front of the bracket, and we're going to apply the distributive law to negative 2x and 5, and we're going to end up with 2x minus 6x plus 15 equals 3. Now collect all your like terms of x's on the left side, and you're going to get 2x plus 15 equals 3. We move the 15 over to the other side, we end up with 2x equals 3 minus 15. We get 2x equals negative 12, and we end up with, in the end, x is equal to negative 6. Now, once we get x is equal to negative 6, we need to back substitute to find our y value. So we're going to sub x equals negative 6 into equation 2. And since we've done that, we're going to get y is equal to negative 2 times negative 6 plus 5, which equals 12 plus 5, which equals 17. And so now we can state that our solution is x is equal to negative 6 and y equals 17, or we can write it as a point, x comma y equals bracket negative 6 comma 17. And we're done. Now moving on to our next question. The first thing you'll realize with this next equation is that after we've labeled our two equations, none of these equations are good enough to solve for y immediately. We can't divide everything out by the same number or whatever. So I choose to take a look at equation number 1, and we're going to solve for y. So what you can do is you can move over to the side and show the math like here to solve for y, and then we're going to take our result for our solution for equation 1 and we're going to put it in our system, and we're going to start with that. So we end up with y is equal to negative 5 halves x plus 3 for your equation 1. And then we have 4x minus 3y equals 14. Now, once we have that new system, we can immediately start doing our substitution. So we're going to sub 1 into 2. And we get 4x minus 3 bracket negative 5 over 2x plus 3 equals 14. And now we're going to multiply by distribution the negative 3 that's sitting in front of that bracket. So let me just quickly highlight that. And then we're going to apply it to both of the numbers in that bracket. So we're going to get 4x plus 15 over 2x minus 9 equals 14. So the next thing that I'm going to do in order to make my life easy is I'm going to multiply everything by 2. So here we go. So we take the 4x, we multiply by 2. We take the 15 over 2 and we multiply it by 2. And you take the negative 9 and multiply by 2, and the 14 and multiply by 2. So now we're going to get 8x plus, well, 30 over 2 is just going to end up being 15 when we cancel out the 2's. So we end up with 15x, and then we end up with minus 18 equals 28. Now, some of you are having some difficulty understanding how you got 15x. The reason why is because when we multiply by the LCM, which is under the 15 in the previous line, there's a cancellation that occurs, and you need to recognize the cancellation. It just makes your life easier. So now we end up with 23x minus 18 equals 28, and then we'll move the 28 to the other side to get 23x is equal to 28 plus 18. And so we now end up with 46 equals 23x, and we go through this math and we end up with our value of x is equal to 2. Now that we've done that, what I want you to do is I want you to back substitute x equals 2 into our original equation number 1. Sorry, not our original equation, our revised equation number 1. So we're going to sub x equals 2 into 1, and once we've done that, we're going to get y is equal to negative 5 halves bracket 2 plus 3. So we end up with y is equal to, well, canceling, you end up with negative 5 plus 3, which is negative 2. So the last thing to do is to just state your final solution. And we're done, guys. So your homework for the weekend is going to be page 26, number 1 and 5. You're going to do the alternate parts for A, C, and E. You're going to also notice you're going to actually do questions number 6 to 10. And I want you to do that for word problems, and then use an extra challenge problem on page 27, number 14 and 15. And I think I'm going to ask you to eventually, and from this set here, I'm going to ask you to do 2 checks. So pick 2 of the questions from 6 to 10 and do the checks once you've gotten your x and y values. do your checks on the two equations. That's all. All right, we're done.